Well, happy New Year's Eve day. This is going to be a great New Year 2023. I'm hoping it's better than 2022. I hope you have a prosperous New Year and that you are safe and healthy and all that good stuff. So anyway, we're getting ready to head out to a New Year's Eve function, but at any rate, I wanted to try to go over a few things with you. It's got a little bit more to do with frequency testing and nailing down any kind of problems that we might have with the Jensen CS315 DIY customization project I'm doing. So I'm just trying to see what's going on with them right now, compare that to what I'm hearing, and then kind of assess where to try to address those. So with that being said, I'm going to go ahead and get set up here and start with the first thing, which is going to be testing what the speaker does now. You hear the music in the background. That's probably, well, I know it's my wife cleaning. She loves to crank it up downstairs when she's cleaning. So anyway, it'll be, I'll turn up the volume on this so that it's getting a better reading on here. But yeah, you can see she's jamming down there. Anyway, so let's get started. All right, hoping this isn't too washed out with the sun coming through the window and stuff, but this speaker's in the furthest corner, so it's away from the music that my wife's playing. So first thing I want to do is try to figure out how this speaker reacts right now. If you remember from the last video I did with the frequency testing of 6 sets of speakers, I was doing it from kind of a equilateral listening position of about 3 feet away from the speakers. So it's going to represent what the speakers do, at the listening area, but it would also cause a lot of inaccuracies in terms of, to really get the feel for what this speaker's doing. We want to get up a little bit closer, so that's what I've done today. And we want to isolate the speaker too. Just one speaker. I don't have a soundproof room or anything like that, so there's always a chance for reverberations from the walls and stuff to affect this too. So it's not super scientific, as always. Everything I do is kind of hillbillies, but bear with me here, and hopefully it'll make a little bit of sense. There's some modifications that I have in mind for some problems I think may be going on. Before I even start though, I want to tell you what I like and don't dislike about this DIY project. So I do like the way that these sound. The thing I don't like about them is something that the Jensen woofer did that this one doesn't, is I think this added a little bit more of the mid-bass punch that I like personally. Now we'll know from the frequency response whether or not there's any issues, any holes, any dips in frequency, sound pressure level with this current woofer. It might be that it's okay, that it's within a decent tolerance, but I just don't like the way that it sounds because it's kind of neutral. Whereas I like a punchy speaker, right? So it might be that, or it might be the fact that maybe the crossover point between mid-range and woofer is not exactly coherent here. And I'll show you a frequency graph for this driver, as well as the mid-range and the tweeter, and then tell you about the crossover points so you can kind of get an idea and see where I'm headed with this idea I have here. So, and this is going to be completely rudimentary. I'm not an electronics engineer, sound engineer, any of that. So, if you are, that's cool. And you can definitely educate me in the comments below. I have no problem at all with understanding how things work, and you know, trusting those that know what they're talking about. So yeah, I'm good with that. What I'm doing here is just trying to intuitively improve a speaker. So with that being said, let me first of all share with you the frequency responses that these drivers should technically have. All right, so I've got this, let's see, let's get to, I had these things open. All right, so let's start with my woofer, which is like a 20-plus-year-old woofer. It's called the Dayton 15-inch Series 2. And I'm fairly confident in my SPL levels of the speakers, which means that ideally when you design a passive crossover, your speakers will have similar sound pressure levels so that it reacts the way that you want it to react. So the woofer has, looks like, I'll try to get a little bit closer there. So it's got 89.5 dB per 1 watt, okay? And let's compare that to our mid-range. Let's see, let's make sure this is the mid-range. Yep, this is the full range, the Dayton 5-inch full range that I'm using as a mid-range. And it has, oh, where's the darn frequency response for this guy? Here it is. Right, so this one, oh, and the SPL level. So the SPL on this is 88.2 versus, what was it on this one? 89.5. So 88.2 to 89.5. So theoretically, the woofer should be a little bit louder than the mid-range. And honestly, that's okay. I think I've mentioned to you in the past that for some reason, it seems like when you build a three-way cabinet, and there's probably an electrician out there or electronics guy that could, you know, comment down below why this is the case. But it always sounds like the mid-range gets hotter to me, like it's more intense. And I've heard that now this crossover inside of this cabinet here is, I could show you that online too. But it even states in the description, and there's been questions and answers on the Parts Express, from the Parts Express text, that the mid-range that is in here is designed with the polarity to be, you know, equal. You don't flip the polarity of the mid-range. So sometimes you do flip the mid-range or the polarity of the mid-range because otherwise it's too quiet. It's got like a suck out in it. But anyway, so I'm counting on that crossover being pretty well designed right now. So I'm just looking at frequency responses, and I'm looking at the driver SPL. And this, you know, honestly, this takes place way in the beginning when you're designing a set of speakers too. So I like a little bit heavy on the bass side. So the fact that this one's 89.5 versus, what was this other one here? Oh, where'd that stupid crossover chart go? Not that one, that's the tweeter. Here it is. Oh, and the SPL, 88.2. So 89.5 to 88.2, that's not even 1 dB. But it's just a slightly higher sound pressure level that the woofer should be putting out. Now here's the frequency response of this speaker. And technically they call this a full range speaker because it does, you know, go down to 20 hertz and it goes up to 20,000 hertz. Now, where we're trying to catch it is in its flattest area. So I figured that to be between 100 on up to roughly about 4,000 is where it's kind of cleanest, especially off axis. These other color lines here is when you get off axis. So we should have good on axis and off axis response in this range, this window. So right now our crossover is set to go at 4,500, which catches it right as it dips down, okay? And I think I've explained in other videos that to me that's okay, because if you have, say, a flat area of one driver and a flat area of that frequency response of the other driver, and then you put your crossover point there, sometimes you'll get like a spike there. Either a spike or a valley. Usually the valley happens when the crossover frequencies are too far apart, and you get the spike when they're duplicating or replicating each other. That's the way I understand it. Could be wrong, but that's the way I understand it. So with that being said, as this one is rolling off, okay, the tweeter should be picking up. The tweeter goes from what, 20 to about 1,000, pretty good, you know, not 20, 15 to 1,000, fairly good. And again, this has this little whoop-de-doo, this rise at the tail end, but that's well past our crossover point. Our crossover point is 4,500. So again, I'm catching it on its way down with plenty of, you know, left over for the 12 dB per octave roll off. So it's not like it's going to have a big suck out there, which is good. So between mid-range and tweeter, that should be good. And the tweeter, as long as we're talking about the sensitivity, this one has a sensitivity rating of 90.3 dB. So again, it's right in that range. It's just a little bit hotter than the woofer, and quite a bit, well, not quite a bit, but a couple dB more, no, about over 1 dB. Yeah, 88.5, I think it was on the mid-range. .2. Yeah, so almost a full 2 dB hotter than the mid-range. So by design, and we were talking about this, or I was talking about this to you in the video I did on the frequency testing of 6 speakers, is that some speakers are designed to have a little bit of a smiley face to them, a frequency graph that looks like a smiley face. It's a little high on the bass end, a little bit down in the middle, and then higher on the high end. So theoretically, in my mind, this is a perfect setup for that because of those SPL levels. All right, so now let's talk about where the strengths and weaknesses lie in our crossover points. All right, the woofer is the main one I want to show you because that's, again, my primary concern. I'll get a pointing device here for you. All right, so if we're looking at 20 hertz, and we drew a straight line, okay, this is kind of how low we want to go. We're just feeling that bass. At 40 hertz, there's 30, there's 40. At 40 hertz is where our bass begins that we can actually hear. And so it's actually got a nice little bump here in the bottom end, up to about 200. And starts to roll off a little bit, just a tick, right? Kind of comes back up a little bit. And then at 500, man, it just starts dropping like a rock. Probably to do with the inductance. As the frequency rises, it's most likely causing some issue here. So I was thinking about even a Zobel network on there, but that's where you go parallel on the driver, but I'd rather stay away from that on the woofer if I can. But yeah, at our crossover point, which is like 800, it's catching it on its way back up. So we've gone down and we're catching it now on its way up. So I'm going to look on my frequency response to see in that area if that dip is causing any kind of issue, that dip at the 600 range. So I'm going to be keeping my eye on that. The mid-range, at that same area at 500, it's solid. 600, good. 700, good. So on and so forth, right? So the fact that we're cutting this off at 800, it's actually a little bit funny because I'm actually getting rid of the best part of that speaker's response. So could I bring that down? Could I cross that over lower, cross the woofer lower? That's a possibility. It would mean getting different components though, different inductors. So that's a possibility. As we're heading into the area of the crossover, now this goes up to 4,500, and you know, we're okay. I mean, being off axis on a mid-range like by 5 dB is not a huge deal up in this range, as long as we can carry over with the tweeter good. And the tweeter in that same range is running solid. So again, I'm thinking that might match up pretty good. So let's see what it does though. Let's see how the speaker runs, and the distance that I've got here is, just for you to see, is roughly 24 inches from the speaker. So that's pretty close, because they usually test them at 1 meter. I'm going to test it a little bit closer. And again, it's because of a lot of the ambient noise, as well as the fact that we're in an open environment. So I don't know where the mic is at on this computer, but we're roughly 2 feet away. And the other thing that I'm going to do, so that I don't have the other speaker influencing it, I'm going to go ahead and I'm going to unplug that. Always turn off your amp or your receiver before you go disconnecting the speakers. All right, so let's get these guys unplugged. And they're not going to short out there. They're just sticking up in the air. So now we'll just have the one speaker running. We could also do this with a level control, but this is a home theater receiver, so I got to hook up a monitor in order to do that balance adjustment, which I don't really feel like doing. All right, so let's get back to our, I'm going to set this guy up so you can see what I'm doing. And let's get back to our, what's this thing called, spectrograph or something? Let's go ahead and, I had done one sweep already. I'm not sure how good you can, yeah, you can see that red line from here. So I had done one sweep already, and what I see from this sweep, it was just, I was holding the computer by hand, but it looks, okay. I mean, it's kind of within its tolerance, but it has kind of a dip here, which is just before the crossover point, which is kind of weird to me. I'm not sure why that is. Same with in the 200 range, that doesn't make much sense because the woofer should be pretty pretty good in that region. And 20 to 40, it should be good too. But you know, we'll see what happens here. I'm going to just run this again. So I'll go ahead and reset this.
Hi, welcome to Dr. Mix. This is a signal test for you.
We're going minus 10 dB. So the yellow line is what it's picking up now. And it leaves that red mark behind where it sees its peak. So at 40 hertz, we've got a bump, which is fine by me. This whole region, the fact that it's a little high is okay with me. This, well, yeah, it's just kind of climbing down gradually. As long as we could wind up with a consistent line here.
If you want to know more about our mixing and mastering services, please visit us on drmix.com.
All right. So here's what I'm seeing. I think it's representative of the sound pressure levels, the dB sensitivity that I had mentioned. So we have a little bit more sensitive woofer, means it gets a little bit louder, a little bit quicker. So you'll see we're a little bit hot there, right? And we know that it has a decline here that happens about 500, but it looks like that's not really an issue here. I don't see that suck out. And then there's a big peak that it showed like at 900. See, now I don't see that either. So that's cool. As we come up above here, now we're in the we're in the crossover range because we're crossing over about 800, which is in here. So right here is where the mid-range and the tweeter, the mid-range and the woofer are making their crossover. So we see a little something funky here, but it's within 5 dB in this room and the way I'm testing it. So, I'm not overly concerned with that. As we get a little bit further into the mid-range section, now the mid-range should just be taking over on up to about 4,500. Now at 4,500, you'll see we do have this kind of peakiness, and we've got this kind of S shape going on here with the mid-range. So the mid-range to me, looks, according to the frequency response, kind of like that's my problem area. The tweeter, that's looking pretty flat on up to where it can't operate effectively anymore. So that's pretty cool. If we move our, this is the line for the peak. So this peak that I'm seeing happens at 5,600 hertz. Let's try another one here. Where's this low point? It's happening at 1,219 hertz, which is in the mid-range region. And that mid-range should have a pretty flat response. Let's see, over here, this little punch is right at 40, 41. So it's kind of cool. All right, so I like that. That gives us kind of an idea of what we're working with here. One thing I do want to try first is to see what happens when I change the port. I want to see if by changing that port, because right now it's tuned a little bit lower. With a longer port, it's got a lower frequency response. It should go down to about 22 hertz or something like that. Which, if we look at our chart here, 20, yeah, so right at 20, it's at negative 50 dB, and then when we get up to at 29 hertz, it starts kind of keeping up with the rest of the system. So I figure this speaker's good to, you know, we could call it 30 hertz. We'll call it 30 hertz. So let's see what happens when I change the port, because that's probably like the easiest thing I can do. Of course, I did put extra electrical tape on here to hold it. I'll get down here where I can see it. All right, so yeah, so this is my port, and I just put a little bit of electrical tape on there to hold it in place, nice and snug. That one won't fit. I would like to try that, but I would destroy the cabinet doing it. So this is the original one. It's just 1 inch long, so it's the same thing. This is called a Helmholtz resonator. Imagine this being like an extra driver. There's simply a pocket of air in here that's being pushed out, okay, creating sound waves. All right, so we'll throw this in there and let's see how our bottom end looks. And I'm going to actually write down, just so we're keeping track of all this good stuff. We'll go ahead and write down 4-inch port. We got, that one is, let's go down to 20. Let's see where we're at. All right, so looks like we're negative 50 at 20 hertz. All right, we're at negative 32 at 40 hertz, give or take. Let's move this on down a little bit more. And we are at our, let's take it to our crossover point, which is what, 800? Oh, where'd you go? Here you go, see all that. There we go. All right, so 800, let's see, we're, yeah, I thought this is most of the woofer. It's pretty flat for a woofer. It's pretty cool. Looks like at 800, we're at minus 30. Now, I can tell you what I think will happen. I have not tried this yet, so I'm not cheating here. But I think what's going to happen is we won't have as much, we'll be lower at the 20 hertz. I think that this point will drop, and I think that this point will maybe get louder, or it may pick it up just a hair in this region. So let's see what happens. And I'll actually leave this on here right now so we can see what changes in that area.
Hi, welcome to Dr. Mix. This is a signal test for you. Enjoy.
That area I hate. I gotta bring that down. All right, Dr. Mix is about to sign out here.
If you want to know more about our mixing and mastering services, please visit us on drmix.com. See you later.
So let's see how we did now. At our 800 mark, we were at negative 30 before. Yep, still there. Okay, let's try our 40 hertz. It didn't change as much as I expected, honestly. All right, so this is now at the 40, it's at negative 28. Okay, so yeah, so it did get a little bit louder in this area. So now we're at negative, here's 30, goes in, is this going 2 increments? 22, 24, 26, 28. All right, so 2 dB increments. So this is at what, 22, 24, 26, negative 26 dB. So it did pick up at that punchy, or the 40 hertz range. And at 20, where we were at negative 50, let's move this guy over here. And we're at actually a negative 46. So that's interesting. So what that means is that the 1 inch long port, so it's 1.755, 1 inch long. That is the best so far, or let's call it better than 4 inch. Okay, so it's obvious that we would want to leave this in there. Okay, you want to see what it sounds like on the bottom end? Put it like that with it out.
Hi, welcome to Dr. Mix. This is a signal test for you. Enjoy.
With that is really close. So having this port in there basically, doesn't do much at all, except give it a better look. All right, so we'll leave this guy in here for now, knowing that the bass response is actually better. Okay, so we've improved the bass response. And let's go ahead and try it on the, well, when I get to the other one, let's just go ahead and do the same thing. Now I want to show you what happens when it's actually more like an acoustic suspension setup. So I'm putting a port bung in here. And let's rerun this test.
Hi, welcome to Dr. Mix. This is a signal test for you. Enjoy.
Oh. Ooh, man, I almost trashed my own speakers. So we're definitely lower in the bass response. I'm just watching the way this yellow thing is following along the last path. So it is lower, but will it clean up this area, I wonder? So no, it's just quieter. Want to see how much, if any, air is coming out of here.
Hi, welcome to Dr. Mix. This is a signal test for you. Enjoy.
This is an open cell foam, but it's the fact that it's crammed in there pretty tight should make this difference. Definitely feel it vibrating, so it is letting some sound out. Let's go ahead and pause that, reset this. Let's see where that occurs at.
Hi, welcome to Dr. Mix. This is a signal test for you. Enjoy.
Above the resonant frequency. It shouldn't matter a whole lot, so I'll pause it here. All right, so fairly gradual slope down to the 20 range. We're at negative 50, which is actually where we were at with the 4-inch port anyway. And let's see, we're up at negative 20, negative 28 at 40. So we're actually still better than the port. So even with the port bung in there, we're getting better performance than we did with the 4-inch port. So that's kind of interesting. Let's see. Another trick I use is at Home Depot. This is just a mic cover, a microphone cover. And then this is like a cap for PVC pipe. Pick that up at Home Depot. I got a bunch of them. But this will seal it completely. That won't allow any sound through there whatsoever. So now this is a sealed cabinet. This is an acoustic suspension cabinet right now. All right, let's go ahead and write down these numbers. So with the bung, it was at 20 hertz. It was negative 50. And then at I'm just rounding up, so it's actually more like 21, 41, but I'm just rounding it up, rounding it off. So at 40 hertz, it looks like it's minus 28. All right. So let's see what happens now with it blocked off. Let's reset this.
Welcome to Dr. Mix. This is a signal test for you. Enjoy.
Take it to its crossover point. Okay. So what we've got going on here, let's see, let's just check our measurements again. We're sitting here at negative, this is sealed. So we're with a sealed cabinet at 20. We are only down by, we're still at negative 50. Okay, so not bad there. At the 40 range, we're still at negative 28. Okay, so the bung really wasn't changing that. It was acting more like instead of a quasi vent, it was acting more like a plug. Let's go up to, what was my other one? 800. Let's take it up to 800. And we're at -30 plus or minus. So we'll go up to 800. All right. Where we started with the 4-inch port, 800, we were at -30, same. 40 hertz, originally we were at -32, now we're at -28. 20 hertz, we were down by 50. 20 hertz, we were down by 50. So honestly, sealed versus ported with the 4-inch, the sealed is essentially behaving even better. So that's interesting. With the 1-inch long, we had the 50 and the 28. Yeah. Oh, 46. That's what we did. 46, 26. So the 1-inch port is better. So, you know, I'm not sure what the Jensen driver is going to do. That would be the next thing to see, is what happens with that Jensen driver in there with it, you know, with its original port. Yeah, so let's go ahead and swap out a driver and see what happens next, okay? I'll pause this. I just thought of something. I should take one more sweep of the bottom end with the 1-inch port and the Dayton driver before changing it, so we can look at what happens. Let's reset this guy.
Hi, welcome to Dr. Mix. This is a signal test for you. Enjoy. If you want to know more about our mixing and mastering services, please visit us on drmix.com. See you later.
See you later, Dr. Mix. Just going for some Something I can mark this with. I want to get a baseline here. Kind of see where we're hitting in the middle. So, and my weighting on this is I believe it's 0.50. So it's still kind of, you know, it's tracking pretty sensitively. It's not smoothing it a ton. But what I want to do here is just see kind of where this thing is best at. And we're just going to call it middle of the road, right? Maybe what about, let's say this speaker is I'll go right about here for right now. I did think of one thing though that I should probably do too. You may or may not know this, but the lower the volume of the speaker, the passive crossover is going to behave differently. So it's just the nature of the beast. I'm going to turn this down considerably to see if we develop any kind of a different pattern, especially up on the higher end, on the tweeter end. Well, bass too. So let's knock it down to negative 25 dB. I had it at negative 15. And let's run the sweep one more time and watch that.
Hi, welcome to Dr. Mix. This is a signal test for you. Enjoy.
And all I'm doing here, trying to see how close it is to this. Okay. Well, from what I can tell, it's
Do you want to know more about our mixing and mastering?
from what I can tell, it's still following the same path. So apparently that difference in volume didn't make that huge of a change. I put this on here. What was my thinking? I don't know, it kind of blocked the view, but I was thinking before I change out this woofer, I wanted to get a baseline for this. Well, we'll just leave this one up here for right now and see how the Jensen looks when we run it. And we're back. So just to show you here, that woofer, I just swapped that out. It's the original Jensen woofer, and I've not turned it on or done anything with it, so everything's just the way we left it, so that you can see exactly what's going on. And now I see that there's a glare kind of in this. Does that help? A little bit. How's that? Yeah, a little washed out looking, but you can see the graph better. So let's go ahead and turn this speaker back on, or the receiver back on, and let's see what happens to our bass response now, especially where it gets involved with that mid-range. So.
Hi, welcome to Dr. Mix. This is a signal test for you.
Going minus
Enjoy.
10. Interesting. Okay.
If you want to know more about our mixing and mastering services, please visit us on drmix.com. See you later.
So we could definitely see that we weren't up in this range. This is the line from the Dayton woofer. But we did, I think it actually did help level out that mid-range just a little bit. Yeah, just a little bit. It looked like it was flattening it out, trying to collapse that band a little bit better. It still kind of got a little bit of a rise to it. If you took and kind of put a straight line through here, looks like it's got a little bit of a kind of a, yeah, it's not quite a smiley, but it's definitely heading up. This here between the tweeter and the mid-range, maybe a Zobel filter on the tweeter might clean that up. But I want to see just how bad this woofer is in terms of response on the low end. So I'll reset all of this. And let's run this guy again.
Hi and welcome to Dr. Mix. This is a signal test for you. Enjoy. If you want to know more about our mixing and mastering services, please visit us on drmix.com. See you later.
All right, let's turn the light here and talk about this a little bit. All right, so what just happened here? I hate it when that happens. All right, so what happened here? Basically, we definitely leveled out in this area. As a matter of fact, I was tracking it while it was playing its test tone, and right when that tweeter picked up is when we wound up with a little gain in dB, which tells me if I attenuated that tweeter, it might even have a flatter line up at the top. As far as the bottom end, still doesn't look too awful bad, and we're looking at our 38, at our 40, 41, 40 hertz. It's down by minus 30. And the best we had at 40 hertz was negative 26 with the Dayton driver. So it's just a little bit lower on the bass end down there. Now at 20 hertz, we were down by 50. Let's see, we better be 50 and 46, depending on which port we used. Which is, here's 20. It looks like at 20, we're actually only down by 46, negative 46. So that's as good as the Dayton driver as well. This is pretty encouraging to me. And I'm going to kind of interject a thought or two here. And this is kind of something I suspected anyway. Was it just because you have enormous, expensive speakers doesn't necessarily mean that it makes them automatically better than something cheaper. Perhaps better design though? That's a possibility. It's certainly lighter. I like that because it's much easier to move around. It was so much easier to put this driver in than that Dayton. Now, the difference between them is power handling. Power handling on this is questionable, probably 80, 100 watts maybe. Just rough guess. Whereas this one, like I'd mentioned, with its 20-pound structure, 20-pound magnet or something, and this 2.5-inch coil, this thing runs at 300 watts RMS with a max of 600. So these, the whole purpose, going back to my original video or second video, I was telling you about this logo, how I got it, Speaker Boy. That was me, 20 plus years ago. My son designed the logo. But this driver was designed for high power, high SPL speakers that were supposed to reproduce an audiophile quality sound in an environment like a recreational environment, a venue, a dance hall, a club, etc. So this driver, very similar in performance obviously, but this one can really take the juice. I used to run each cabinet I built, I ran them with a 2500 watt RMS amp, and oftentimes the full throttle. So these guys, these guys were moving around like crazy. They weren't just sitting there still like you see them in the room here. I mean, these put out some serious sound pressure level, which is cool, but we don't necessarily need it in an office or a bedroom if the frequency response isn't as good or if they don't sound as good, right? So even though it's a better speaker and better for a certain application, doesn't necessarily make it best for this application. So I'm just going to plug back in the other speaker. We can kind of hear them back and forth and see what they sound like. Came over here to pause the video. Okay.
Every time
the same volume I doing the testing at -10.
Just like me, they long to be close to you. Why do stars fall from the sky every time you walk by?
Sounds pretty nice right now.
Just like me, they long to be. Do that to me one more time. Once is never enough with a man like you. Oh, do that to me one more time. I can never get
We'll pause it here and turn on the other speaker.
you.
All right, just like usual, I had a thought come up right at the tail end here as I was cleaning up, and I put the other Jensen driver in here. So anyway, I wanted to hear them together, and I thought we could share that. I could share that with my viewers because I have not listened to it yet. So I figured I'd turn it on, and we'll try to listen to some of the same music that was in the previous video with the frequency testing between the different speakers. It's all on a CD, a RIP CD from like 20 plus years ago. But yeah, let's listen to a few tracks, or bits and pieces of tracks, and you can kind of, if you can hear it well enough through that Pixel 7 microphone, maybe you can kind of help me assess these. So let's see what happens.
done so many things wrong. I don't know if I can do right.
Well, I'm not sure about you, but to me, it sounds really good. It sounds nice. It's got a lot of that mid-bass presence and mid-bass punch, which I really like. It still reaches down low. It's not room shaking low like the other drivers were, but it's low, and that can be, honestly, in an office, that's preferred. We have neighbors too, so obviously the less vibration the better, because that's really all it does is it puts that vibration into the room. Not something you can necessarily hear, more you feel it. So yeah, if I needed to augment it, I still have a subwoofer too. So if I wanted to add bass to it, let's say.
This morning I though I must have walked in the shadows, still searching for the light. Won't you put your faith in me? Oh no, that's what matters. Give me a chance. I'll try.
The subwoofer made basically little to no difference with these speakers. I'm gonna have to measure this sub. It's probably running close to the same frequency as these. It's just a 12-inch driver in there. But heck, maybe that'll be my next project, is building a subwoofer out of these out of these drivers here, because they're really not good for that mid-bass punch that I like so much. But they're still good speakers, and they're really high power. So yeah, coming along good. I'll catch you on the next one. I'm interested to run these sweeps again, and then try to dial in that tweeter a little bit better and see what happens. Right now, just the fact that transition got cleaned up, it actually sounds more spacious and got more depth, more clarity, as well as the punch. So it sounds like a larger speaker, honestly. The other one didn't have a large sound until you turned up the volume, in which case by that time everything's shaking. So that's not the greatest for a home environment, but yeah, pretty pretty cool the way this is coming along. So thanks for coming along on the journey. Happy New Year.